Mr. Morris, today you're going to be completing the rolling ball lab. You should already have the handout or get one of those before you start. To do that, what you're going to need to use is LoggerPro. And you'll need to use one of the 8 computers that I have here, the MacBook Pros, for the software that's on them, as well as the file for the lab. So first thing you'll do is you'll go to LoggerPro and find it in the dock at the bottom, just like I'm doing. Click on LoggerPro and let's open that software. Now once it pops up, you should have this blank data screen that's not doing anything at this time. To find the rolling ball lab, it should be downloaded somewhere onto your hard drive of this machine already. So on any of these 8 computers, you should be able to go to Finder and open it up, and then go to Downloads. And if you look through the downloads, you should be able to find the, come on, there it is. Okay. You should be able to find somewhere the rolling ball lab. So I'm going to search for it instead. Rolling ball. And notice I've got it on here a bunch of times. I've got a folder here and where it's been downloaded many times over the past few years. First one, it looks like in 2013, and et cetera, et cetera. So I've done this a few times. So any of those files that say rolling ball, you should be able to open. And you're going to open this CMBL file that's right here. Now, if you read through the lab handout, I'm going to show you some of this stuff. You read through the lab handout, when you get to section 2, part A, it asks you to open the QuickTime Player movie, Galileo's Projectile. That's here. You don't need to do that. So as they're walking you through the handout, what they want you to do is open the video and watch the video first, and then they actually have you open the rolling ball CMBL file. I'm going to have you just click on the rolling ball CMBL file. Now you'll still need to do part 1, preliminary. Okay, but once we open this up, here's the video that they wanted you to watch. So they wanted you to open this video first by itself before you opened it with the rest of this position and time graph and this data table for the video analysis. Okay, this is what you would have seen if you just opened the Galileo's Projectile file, which is in part 2, section A of the handout. Okay, so when you get to section 2, part A, okay, you've already kind of looked at this. I'm going to show it to you now. So we're going to stretch this out a little bit so we can see it better. And notice all there is a ball sitting on a table. It's a billiard ball and it's rolling across a nice hard flat surface. And they ask you to predict what you think will happen as it rolls. Is it going to speed up? Is it going to slow down? Things like that. That's on the first page. They also ask you to make sketches of what a graph would look like for speeding up, for constant velocity, and slowing down. The purpose of this lab today is not really for the physics of the motion, although you'll get a little bit out of that as well as with the graphing. But the real purpose for this is to introduce you to this software. Some of you have used LoggerPro before with the probes so that you can, I would bet most of you for motion detectors, and the motion detector data and graphs are caught right on the screen of the laptop as you're using LoggerPro software. One of the capabilities of this, and it's probably the best capability, is that you can use it to analyze videos that you make. So I could send you outside to analyze the video of a rocket taking off. Maybe we have a toy rocket that's going to take off, and you make a video of it. You can then bring the video back in and put it into the LoggerPro software, just like this ball rolling videos here. And you can use this software to analyze the speed, the motion, the position, even the amount of acceleration the ball goes through. And it does that by using the video as a timing device. So most videos at this point in your cell phones will capture at 30 frames per second, sometimes 60 and even 80 frames per second. So the frame by frame counts as a very good timing device. Now if I play this, so I'm going to click down here on the play arrow. It's really tiny. Notice it's just a ball rolling across the table. There it goes. There it goes. There it goes. There it goes. Nothing exciting. Okay. But if I put this thing back to where it started from, I can actually move frame by frame with this too and show where the ball is. Each time I click, the ball moves a little bit, a little bit, a little bit. Now if we could measure the distance it moves each time I click from here to here, okay, we could then use that to calculate its velocity pretty precisely. And we can tell if it's speeding up or slowing. So all I need to do is be able to measure how far it is from here to here when I click. Okay? And there is a way to do that on the software, of course. So I'm going to bring this back again and rewind. The first thing we need to know, though, is if I'm going to click on the screen, it's going to capture a pixel point. okay, the pixels on the resolution of the screen. And if I frame forward to the next frame, then all I'm going to do is be capturing another pixel point, okay, and showing where it is on the screen. I need to know if it moves, let's say 400 pixel lengths, I need to know how far that is in distance. And of course, that's why we have this meter stick in the view here. So the first thing you're going to need to do in your video, I'm going to bring this back, is we're going to go to this point right here. I'm going to hover over it. Notice it says set scale. Okay, so I'm going to click on that to set the scale. And what we do is we come down here to the very bottom of the meter stick. I'm going to click there. I'm going to drag then, see the green line. I'm going to drag up to the top of the meter stick, and then I'm going to let go. And what it does, it says, I don't know how many it is. Let's say it's 10,284 pixels. And now it knows that 10,284 pixels is exactly 1 meter. I'm going to click OK. It usually defaults to a distance of 1 meter, and we put meter sticks in our view screen. However, we've done it with other units too, and you can choose different units if you want to. So I click OK, and now the scale is set. Okay, now I'm going to go up here to this little Add Point tool. Okay, so it's a little red section here. I'm going to click on that. Notice now I have my crosshairs again. And all I'm going to do is come over here and click where the ball is. So I believe in the directions. They ask you to start doing this in section 2 around part C and D. So part C and D is where they have you scaling the movie. So the beginning part of this is stuff I've already shown you, and you're not really going to need to do. I would answer the questions in 2A and 2B, but you do not need to open the QuickTime player and show the Galileo's projectile movie. Okay, again, that's just this movie right here. So now I'm going to come to the ball. I'm going to click right on the ball, and notice when I do it moves forward a frame. Okay. And I'm going to move forward with it. And I'm going to find the center of the ball again. I'm going to click again, and it moves forward a frame. And I'm going to click again. Oops, I was off that time. It moved right before I clicked. Let's get one more good data point. Now, the good thing about this software is, as opposed to something like Excel, where you have to put your data in, it is automatically collecting my data for me. So right down here, I've got my numerical data. It's telling me how far it rolls each time. 0.12, 0.07, 0.02, and it actually is using, notice the timing device, 0.033, 0.067, 1/10 of a second. So I believe that is, 30 frames per second? And then it's calculating the speed from that right over here. Notice it's also plotting a graph of that. So I've got 4 dots on my screen that take up pretty much the whole graph. Now if I make another dot, if I collect another data point that's outside of the parameters, let's say, okay, the maximum here is 0.1 on my X scale, and the maximum over here is just over 0.1, maybe 0.13 or 1.5, I don't know what the scale's set at. But anyway, if I click on another point, it would be out here and off the screen. Well, what it does is it automatically adjusts the window and adjusts the scale. So when I click here again on the ball, it creates another point, but notice the point is not off the scale. I now have 5 points in my window. So it took and it shrunk the scale down a little bit so we could fit, or in other words, open the window wider so we could see this data point. And every time I click a data point, it's going to keep those on there. Okay, so let's click a few more. Dot, there it is. There it is. And notice to the right, it's making those little red dots in my movie. Again, and they want you to go all the way to the end, so I'm not going to finish that. The next thing it asks you to do, though, notice, and I don't know what your prediction would have been, if I told you I was rolling a basketball across the grass or across a baseball across some carpet or something like that, you could picture the friction is going to cause the ball to slow down. And so in part 1 of this handout, it asks you to make predictions, and usually the prediction, I'd say 50% of the time with students, is that it is going to slow down. Now, you've obviously watched the video and you're seeing my data here before I've even had you answer the questions. So it looks like a very nice linear graph here, which means as far as slowing down, it doesn't slow down. Every time interval, it moves the same distance. And in this time interval, it moves that distance. And in this time interval, it moves that distance. So every time I have a run, I have the same rise. Move over a run, have the same rise. Move over time, same distance. Time, same distance. Time, same distance, which means it is going constant speed. Now, the other thing that's good about this, as opposed to collecting this data over here by hand, okay, and then having to graph it, is I can quickly put a best fit line on this by just going right up here to where it says linear fit. So I'm going to use the linear fit tool here, and once I click on that, it draws a best fit line through it, and it tells me right in this window, I know it's hard to see, but you'll be able to see yours. I don't think I can expand that in any way. Let me try. No, it doesn't look like I can move it around, but I don't think I can make it bigger. But right here it tells me my slope, and that my slope is 1.506, and it gives the unit of the slope in meters per second. So this is what you're going to do on this. And this software will even work for curves, where you can let's say I had instead of a straight line, I had a curve that was going across the screen and getting flatter as it went up. So increasing velocity here and then decreasing and leveling off to a flatter curve. I could use this tool to even select different sections of the graph and find the slope in those. So let's say I liked my data in this section, but I didn't think my data was real consistent out here. I can just highlight the section of data I want, and I can do a best fit line just for that section. Now, because this is linear, the best fit line for that section is pretty much going to fall through these points too. But I don't have to include all of my data every time I'm doing a best fit line. Okay, we're using the slope here. It gives me my velocity. Notice with just those data points, though, it did change a little bit. I think the last one was 1.5 something, and again, you can't read this because it's too tiny, but now it's telling me 1.499. So it did change a little bit when I only used these 4 data points as opposed to all of them that was there before. My best fit line's a little bit different. And notice over here on the table, it highlighted, I guess I only used 3, it highlighted the 3 data points that I actually selected from the screen. To get rid of that, we just close and click, and then I could select, these data points instead for a best fit line, and go right back up here and do it again. And now it's telling me 1.46. So my curve's a little flatter here than it was before, which actually might make sense because I'm sure it does slow down a tiny bit. But we've got a billiard ball rolling across a very hard table, and it's only rolling for what, like 1 second? Not even probably. So the amount of speed it's going to slow down is not very much. My basketball rolling across grass, I would probably see this thing going on this line, and then it would start leveling off down here, and it would reach this point like where it stops and it's not moving, and my graph would be flat. So I would expect if I'm rolling my basketball across the grass, I would see something that curves and flattens out and ends up down here instead of continuing to go straight all the way up. Hopefully that works to get you through this handout. Let's try and complete that by the end of class. And I apologize that I'm not here today. We will pick up with some other stuff on Friday. And then likewise, I want you to go through and try and do some calculations from the video, the other video I'm going to have you watch. Thank you.